So let's try out a new toy. This is a star tracker that we can mount a camera to and track the night sky and take very long exposures of deep sky objects. Getting pretty good results with just a regular camera and lens, no telescope involved. So like a lot of photographers that I know, the Neowise comet came by and has gotten us all into astrophotography. So we went out and took pictures of the comet with just a stationary tripod. Got pretty good results. My wife actually brought out her iPhone and handheld at 3 seconds she got this photo. I thought that was pretty amazing. Some of these though, if you zoom way in, you can see that there is actually motion blur in the stars and the comet. And this is because the Earth is spinning, and so the entire sky is moving relative to us if we're stationary. So what we need is something that will track with this rotating sky to freeze it in place, just like we do with any moving subject. This is Polaris, and so we can use that to find the celestial North Pole. Right next to it is the actual celestial North Pole. We need a device that will point at that and rotate with the Earth. Look at the Skywatcher Star Adventurer. So it's an extremely simple device. It essentially is just a motor that rotates very slowly. The idea is that you align this device with the celestial poles so that it's in line with the axis of the Earth, and it spins at the speed of the Earth, only in the opposite direction to counteract the rotation of the Earth and causing the sky to be frozen in place. And you can mount cameras to it and take pictures. So that's the basic idea. What you do to get it aligned is take this cap off and take the back off, and this is a polar scope. So you visually align it to the North Pole. Now in the Northern Hemisphere, that means you're looking for Polaris, the North Star, and trying to line that up in the reticle. For doing the polar alignment, you might find that when you look through the scope, you're not able to see the reticle. So you need to be able to see the markings on the reticle to be able to line up the star. So there's this little piece that comes with the system that just slips in here. And it's just a little red light. I'm not sure if you can see that, just barely. But it really helps to light up the reticle against a dark sky. It is possible to do the polar alignment earlier in the night when the North Star is visible but the sky hasn't darkened yet. But otherwise it's a pretty handy thing to have. So first we take this equatorial mount, and it just mounts just like a tripod head. This is a Manfrotto 055, by the way. And the next piece is the actual star tracker itself. Just slides on there, tightens down. Then we would normally take off the polar scope cap, the little cap there. Do our whole polar alignment routine, or maybe first mount the cameras and things to it. So we'll go with this declination bracket versus the ball head adapter. And so that's how that goes. Then one more piece that we didn't show actually in the other video, but once you get a bunch of cameras on here, big lens, big camera, you may need a weight to counteract that leverage that the camera has. And so this is kind of nice, a little rod with a weight on it, and you can just loosen this and slide the weight back and forth to get whatever leverage you need to balance it. And we'll show that in a minute. Finally, it's nice with the declination bracket that we can still put our little lighted reticle on there and just leave it throughout the night. So now we have the whole system set up and presumably tracking. And from here we can either put a ball adapter here, and that way you can mount a camera and point it anywhere you like. Or you could put a ball adapter here also. But what we're going to do is just attach a camera directly to the top of the declination bracket. So here we go. I actually normally shoot Sony these days, but that is what's recording this video. There we go, so you can mount a camera on there. And now the first thing you want to do once you do that is check the weight. That's what this weight is actually for. You can see this is much too heavy. The camera just starts falling. But we can slide this weight down. Still a little bit too little. Slide the weight all the way to the end. So you can see here with a 1:400 lens on a Canon
as the 7D Mark II. That is just about the limit of this system. So this is pretty good. So this means we can point the camera in anywhere along the, let's say, right ascension. We can lock down this in any position. But another little clutch is this guy, and then you can move the camera this way, all you like. Or you can tighten this clutch down and use this knob to make very, very micro adjustments to the direction the camera is pointing. So between these two, you can basically point anywhere you like. The orientation might be a little weird, you know, but you can literally point the camera at anything. And just lock this down, and now the camera would be tracking the sky, pointing at whatever's over there.
Alright, so let's take this outside and do it all again and see what we can capture. So I've had this device just a couple of weeks. I've been outside every single clear night though, learning something new every single night, and getting some results that I didn't realize were even possible with just a regular camera and no telescope. I'm going to start getting into more advanced things like auto guiding and whatnot, and I thought it would just be fun to start making these videos, and any other photographers that get into this sort of thing can follow along. Let's see what we can do.